You guys have the crescent. Thanksgiving is
Well, this is a stimulating conversation.
No, you know those Hawaiian, you know those filled like
Let's
the dough
gather
boy and
ourselves in your
croissants?
phone in the
That's
door.
what you have on Thanksgiving.
Oh, okay, I'm sorry. Very sorry.
All right, let's gather our thoughts in and let's finish up. Last time we were doing the check your understanding for the how often should you take Dayquil paper. And we just did not get to the last question, but I think we can do it pretty quickly. Let's see if we can get that last question. The one where we're on the Great British Baking Show. I do like pumpkin pie.
Arguably the best pie.
Actually, I like the pie part and not the crust.
My dad
I think-
do you like carrot cake? And it's so good.
Oh, carrot cake.
Carrot cake is.
Carrot cake.
Is that
I think the
best?
fact that you only get
Alright,
pumpkin pie
here we
like
go.
once a year makes it
A
like.
contestant takes their cake out, puts it in a refrigerator, temperature set. After 10 minutes, the cake is now cooled to this. The temperature of the cake can be modeled by the equation. Okay. Find the values of A and B. Now, did you notice that in the problem and all those words, we have a couple of ordered pairs? What are the ordered pairs we have in there? 0, 180. After 0 time, the temperature of the cake is 180 degrees. And then what did you say? 10, 150. After 10 minutes, now the temperature of the cake is 150. So where do we go from here? Plug them in. So let's see what we get if we put in 150 or 180. I mean, so look, this is y, this is x. So 180 equals a b to the 0 plus 3. You okay with that? So 177 equals a b to the 0. What's b to the 0?
1.
So 177 equals a. So now my equation is c of t equals 177 b to the t plus 3. You okay with that? So what am I going to do now? Plug in my other point. So 150 equals 177 b to the 10th plus 3. So what does that leave me with? Um, 147 equals 177 b to the 10th. Now what? So 147 over 177 equals b to the 10th. And then I'm either going to 10th root or raise to the 1/10th power, whatever's easiest for you. So b is going to be 147 over 177, basically the 0.1 power. Did you get like 0.9816? So my equation, what was A? 177, 0.9816 to the T plus 3. And then the last part says, what will the temperature be after 45 minutes? So that's easy, right? Just plug in 45. So yes, 79.74 basically degrees. We want to talk about that in the equation. What's going on here? What's that, Alex?
Is that they make up the asymptote free so that when, if the cake spends infinity time in the refrigerator, then it's
Exactly.
minimum is 3 degrees.
We know this cake is cooling off, right? So normally the exponential would look like this. 0. But the problem is we got it in a refrigerator and it's not down to 0, it's down to 3. So the asymptote's here, so as that temperature keeps coming down, it's never gonna go past 3. Because it's in the refrigerator.
So is A not the initial value? Because I thought A was like T of 0, so I thought it would just be 180, but it was 177.
Yeah, because you have that plus 3 added on.
Okay.
Remember, the initial value is the y-intercept. And when you do something to the y's, like adding a 3 onto the end, then that's going to change your y-intercept. So the initial value is the value of y when x is 0. So it is the y-intercept.
That
Okay?
is, yeah, okay. Alright. Okay, I get it.
Okay? Okay. All right. Okay, now, next page. Competing function model validation. Oh boy, what does that even mean? Well, our priority in the last few problems has been linear, or last few days, linear, quadratic, and exponential functions. And Mr. Passwater does a great job explaining the differences in here. You already know that, most of it, but the idea is, in the real world, you don't have a lot of relationships, for example, that are cubic. But you have a lot of relationships that are parabolas, quadratic. Things go up and they come down, like a ball in the air, kick a football or throw a ball or something. We have a lot of exponential things, growth, decay, a lot of those. And we have a lot of linear things. The more bananas I buy, the more money I pay. Right? The faster I go, the more miles I cover. Lots of linear, quadratic, and exponential relationships in the world. So those are kind of the focus of the course. So if you look at example 1, he wants you to decide what kind of model would be most appropriate. We have techniques to do that numerically, but he wants you to just sketch a quick little scatter plot. So go ahead for these 4 problems, plot the points he gives you, and it's just approximate, just do the best you can. Do a quick scatter plot, and see if you can decide whether these would be best modeled linearly, with a quadratic, or with an exponential. if we tried to do that numerically, what do you notice about your y values? Your x's are all equally spaced, so you're good. What do you notice about your y's? They're going down by not exactly the same amount, but aren't they going down by approximately 3? And that's a linear relationship if they're going down by approximately the same thing. Okay, what did you notice about b? Quadratic. And if you look at those y values, they start out going up, but then what happens? They turn around and go down at about the same rate that they went up by. So kind of symmetry in there, quadratic. Okay, how about C? C is exponential decay, going down. And D was actually exponential growth, going up. Everybody good with that? Now we're going to do some review. Residuals. Important comment here is the middle one. When using a model, it's important to remember that it's only a predicted value. So when you write an equation, it is your predicted value. Okay, and Declan, I just want to back up. I just thought of something. For that question that you were asking about, because you thought the initial value should be 150, and the 150 is the value when x is 0, right?
Yeah.
And that has to be the point. So if you were going to put that in for a, then your equation would have looked like this, or not 150, but 180 or whatever. 180, whatever b to whatever was plus 3. Now what happens if you put 0 in there? Okay, which is not a description of the problem, right?
Yeah.
Yeah, okay. All right, so let's look at example 2 and review doing residuals. Okay, we got our baby being born again. Use the regression capabilities on your calculator to find a linear model of the form a plus bx. So do you remember in the regressions, you had 2 linear ones? One was ax plus b and one was a plus bx. So he's telling you to use that one for some reason. I don't know. Go ahead and do it. Put in the data. So stat edit, everybody remember? Is that what you got? Okay, and then it says, use the model to find the weight of the baby at 2.5 months after birth. These aren't rounded off, it doesn't look like, so it should be okay. But I'm gonna go ahead, I stored my equation, so just to be safe, I'm gonna put in y of 2.5, and I got 5.34. What's my unit? The actual weight of the baby was 5.5 kilograms. So remember, this is your predicted. The actual was 5.5. How do we find the residual? What's our little formula? Actual minus predicted. So it's gonna be 5.5 minus 5.34. 0.16 kilograms is my residual. Did our model underestimate or overestimate the weight of the baby? Under by 0.16 kilograms. Now, do you remember how to do the residual plot? Okay, let's do that. If you've forgotten, ask your neighbor, because I heard somebody ask. There's people out there who remember. Let's go ahead and, remember the zoom stat. That will usually, help you get a better picture.
Is there a reason for it to look like a problem?
We were talking about that. We're gonna talk about that. Did you get your plot? Okay. If a model for a given set of data is appropriate, the residual plot should appear without pattern. So remember, we did a linear regression because that's what he told us to do, right? So now we're kind of checking, was that a reasonable model to use? If a model is appropriate, the residual plot should appear without pattern. That means it looks like this, okay? Right? What do you think? Declan said, should it look like a parabola? The answer is no, it should not look like a parabola. So what does that tell me? I probably didn't pick the right model for this data. Now, I'll be the first to admit linear makes sense to me in this situation, but the equation I'm using is not good because it's very predictable what the residual is. All right, so let's look at number 3, example 3. An exponential regression, we use the model, okay. Which of the following is the best conclusion about the appropriateness of the exponential regression model based on the corresponding residual plot? So, somebody said, okay, I got this data, it's exponential, they got an equation, they graphed the plot, the residual plot, and they got that picture. What do you think? The exponential model is appropriate because the residuals show no pattern. It's completely random. Not predictable at all. So example 4. Row 1 did linear, row 2 did quadratic, row 3 did exponential. Based on all that, which model is the most appropriate? Exponential, because it shows no pattern at all.
So like on the last one, example 2, where we did the linear one, if the residual plot looks like a parabola, would that mean it's a quadratic regression?
I don't know. Not that I know of, but I don't know.
Yeah.
I don't know. I'm not a real stats person. I haven't spent enough time with residuals to know that. I don't know. That's close.
I think the second differences of that table equal, so it probably
Are
is.
about the same number.
Yeah, they're roughly the same. They're all
Okay.
Yeah, the residual is pretty low. For the,
The quadratic.
I I just
So
went
our squared is pretty low, it's 0.9999.
in the table.
For the quadratic?
Yeah.
Yeah.
In the table, it gave us all the rates of change, like it works in quadratic.
I just don't know, I don't know if the pattern of the residuals gives you the most appropriate model. I don't know that there's that connection. There might be, I don't know. I don't know. But good for looking at the data points and saying, the second differences are the same, or close to the same, so it should be quadratic. All right, example 5. Should Mr. Passwater use a linear, quadratic, or exponential model in this situation? All right, let's think about this for a second. What's happening? He's gonna paint some circles in various sizes. He's gotta figure out how much paint to use. What's your thought on A? Why? Pi r squared is quadratic, absolutely. He is doing area to paint, right? And the formula for area is pi r squared, any area. I mean, area period is squared units, so it makes sense that it would be quadratic. Good job. All right, so he creates the model, goes out and buys paint. Do you want the model to over or underestimate the actual amount of paint needed? Over, why?
Because then still be able to finish.
Then he won't run out, exactly, yeah, he can finish the job. Now, you wouldn't want it to be hugely over, because then he's going to waste money on paint he doesn't need. But yeah, I'm with you, totally on that. All right, we're gonna skip the eating out problem, because I don't have that software. So we'll go to the check your understanding on the last page of the notes. Check your understanding. With your partner, let's answer these 3 questions and get them up here on the board. So spend some time on that last page, check your understanding. The least squares regression, your calculator does that for you, so the regression's done, you don't need to worry about that. AP test, you are gonna have to be able to interpret results. So that's what this is all about right here. Figuring out what's going on and explaining your absence.
Not in, like, we like we did. I'm so down with that shit, that's my favorite. I don't
Okay, anybody got one?
even on the back, just
Alright, well, let's talk about two then. Alex says, should it be linear, quadratic, or exponential? Alex says linear because if you try to draw one line through that data, he says, it looks like it's going like this, right? I see a line going like this. I agree with that. Looks linear. And then, so we decided to do a linear from what we did. We came up with an equation, and Declan says he thinks it's appropriate. Do you think that model is appropriate based on the regression plot? Absolutely, because look how random that is. There's nothing going on there. They're just all over the place. Perfect. What does the slope mean? So the slope of our equation is negative 0.0146. What does that mean? Remember, slope is a rate of change, and a rate of change has a unit on it. So what is that? Negative 0.0146 what? Points per absence? We got a GPA point, so points per absence, right? So every absence results in a loss of 0.0146 GPA points. And then what happens if we have 23 absences? About 3.2? Is that okay? Alright, how come nobody said number one? What'd you say?
Negative correlation.
What?
Negative correlation.
Oh, so there's a negative correlation. Generally speaking, what happens? The more times you're absent, the lower your GPA is. Negative correlation. As absences go up, GPA goes down.
110 absences, 0.2.
Generally speaking. Obviously, that's not true for every kid in the plot, but generally speaking. Woe be to the kids that missed 110 days of school. I just thought that, have you ever seen the movie Animal House?
Oh, yeah.
No. Oh my God. The dean of students, there's a fraternity, and they're terrible. I mean, they're Animal House. And, but the dean calls them all and talks to them all about their GPAs. And I mean, you hear things like, 1.3 and 0.7. Then he gets to the last guy and he says, looks at him and says, 0.0. I guess you have to be a teacher to find that for him, but I found that.
0.0 is gotta be there.
Oh, I heard this. No,
Alright. Okay, let's get out our review materials that I gave you the other day. Remember, we all picked up, these papers. I gave you 3 of them. And let's start with the one that looks like this. It's just says review 2126 at the top. And it has A through M, so however many that is, it has not any problems. Let's just start working with our partner, group effort. You can turn around and work in groups of 4 if you want, I don't care. But let's see if we can get this done, talk about these before we have to leave.
this is still my favorite picture of all.
So we're on the one that says review 2-1 to 2-6.
Yeah, I have
A through M.
Yeah.
I'm gonna have you put some answers up. As we go.
Is state road?
You're pretty good.
So what'd you get the first three?
Wait,
You
D
feel
could be.
comfortable putting it up there? Go ahead.
Well, Ms. Ford,
Yeah.
for C, it says hours worked to money earned at the job. If the hours
Wait.
is high enough, you can get like a promotion, causing it to be exponential.
Oh, you're talking about problem A, part C?
Yeah.
Okay, what's your question again?
So hours worked to money earned. If the hours is high enough, then you get like a raise or something, causing it to be exponential.
I think this is just talking about, you have a job right now at Dairy Queen. What's the relationship between the number of hours you work and the money you get paid?
Brother,
No,
Yeah, so you're right, certainly things could happen.
Price of Top Golf. Dude, I'll get them tonight for free.
You gotta give me some. Can I pull up to the parking lot?
Just like throws it out.
Is it X divided by 2 or X? 2? Why is that?
Sure, I think that looks like counts or decay.
Yeah. Because if you have 6 people on one account and you divide the price by 6 people, you're only paying
Cost per
30 divided by 6, 5 per person.
Stage 4.
Wait,
Yeah, so he wants to raise you.
Are they saying like some friends share a Netflix account?
Yeah.
And not just not like not like family, right? Obviously kids that do that.
Your brother? Right now? He's on stage.
Hey buddy, you're really far behind.
Yourself.
92. 3. B's answer C on B.
You're looking alright up there, big guy.
Shouldn't that have come before?
Did you read the equation down?
I don't know.
No, I'm just confused why it would have us put the equation in the last question. Yeah, that's right.
When you're done with the first three, keep going.
Or triple over 2 days. So it just be 92. 2/3 in there somewhere. Triples. I'll be 1/2, 10. Should be, I think 1/2. So 92, 3, 1/2.
Yeah, right.
And then what, 4?
Bro, quit drawing windows on my paper.
Yeah, that works.
You are trying to
Yeah, try to finish. Is that just stinky?
C. Is that, what's that equation again? It's like A equals PE. Oh, C.
What are you doing up there again? What are you doing up there?
Holy ball.
Oh, it's just the.
Yeah,
Oh, it's just.
Okay.
Just
Explain.
Well, this should just be, because triple in 2 days, day 1 would stay the same, day 2 would triple. So it'd be 92 times 3. Day 3 stays the same, day 4 triples again.
Introducing your
Day 5
time
stays the same,
exponentially.
All right.
I don't think it stays the same, I think.
Let's give Al a chance to finish up here.
I'll hit you with the elements.
That's right. Well, I got 14, 34.
And let's talk about these. Okay, let's look at A. So if it says growth or decay, you mean exponential growth or decay, right? Okay. So what do we think? He's got A, B, and D, he has as being exponential. C is neither, because without making the problem overly involved, the more hours you work, the more money you're gonna make, and that's a linear relationship. So 1 hour might be $15, 2 hours would be $30, and so on, right? So I agree with him 100% about that one. I'm a little confused about D. Did anybody else, did you all think that was, it said on decreasing. Maybe I don't understand the problem because I don't have Netflix, but here's my assumption. It costs $100. So if 2 people are on it, then it costs, oh wait a second, maybe I just took myself out of it, then it would be 50. And then if 4 people are on it, it would be 25. Is it going down by the same amount though? What if 3 people
No,
are
it's
on
half.
it? Well, it's not having.
Well, it is.
It's divided by
Divided.
people there. Wait, no, okay, so it goes 50, then 33. It's like, yeah, no, it's not going down by the same each time.
50 then 33 to 25.
Just divided by how many people are on now.
It could be.
It's really over adding.
I don't, to be exponential, we have to be going down by the same percent, right? Or going up by the same percent? And we're not?
Wait, so is this geometric instead?
No. No, if it were geometric, it would be exponential. Remember, they're the same.
So Ms. Ford, it also, you can only have like, I think 5 or 6 people in the same account. I don't know if that matters, but like,
I don't know.
it stops.
I don't think it's exponential though, because it's,
What?
it's going down.
It's real rooms.
But by,
I just, the graph looks exponential. And it keeps getting closer to 0.
that's true, that's true. I gotta think about that. I gotta think about that. I agree with A and B though, are you okay with that? A
Oh,
and
wait.
B?
For like D, like the capital B,
Last one, my equation is different. I'm like confused.
Here?
Yeah.
Okay, well, let's look at that one then. How many fruit flies are there on day 4? Did you triple twice and get 828 fruit flies? Good. Now, day 5 is problematic, isn't it? Because we're tripling every 2 days, but 5 isn't and every 2. So we talked about this yesterday or some other day. We talked about this. That, okay, so our general formula would be we're starting with 92
X over 2.
and we're tripling every 2 days.
92 and 3 to the X
But we
over
need
2.
to adjust that to make it every day.
I got 92.
So that would be every day. Does that make sense to you? So if you put a 2 in here, if you put a 2 in, that would be 1 triple. Is that what you want to have happen? Yeah. And if you put a 4 in there, that would be 2 triples. That's what you want to have happen. So this is our formula right here. So if you put in 5, I don't know. What do you get when you put in 5?
I have 1434.138.
Kellen, can you have .138 over
1434 is what I got. Is that okay? I bet that's because of the roundabout there, here maybe.
How do you get that?
Because your formula, this number right here, would be 3 to the 1/2 to the t. And 3 to the 1/2 is the square root of 3. So actually, it's 92 root 3 to the t would be your equation. You put a decimal in there, I don't know if that's root 3 or not, but that's what caused you to be off a little bit.
Are we allowed to just keep it as t over 2, or do we have to do that?
No, I think it'd be fine to keep it as t over 2. Yeah, but if we wanted to know the growth rate per day, we would have to look at the decimal, we'd have to look at this, this is the per day number. All right, good job. All right, and what about C? What did we say here? No, percentage, that means the ratio is staying constant. So that isn't arithmetic, that is geometric. Absolutely, that's geometric. All right, let's look at the next ones. And see. Remember there.
She's gonna walk by. He's up there. He's gonna hold it. Hey, don't go by.
Oh, we're almost out of time. Let's at least get through D. Okay, what have you come up with for D? Did you come up with anything yet? What's the parent function? Y equals 3 to the x. What have we done to it? We've gone right 4 and up 8. So if you take your exponential and you go right 4 and up 8, then what's your domain? Negative infinity to infinity. And what's your range? 8 to infinity, and those are open intervals. Very good. What are the do we have any asymptotes in this? Absolutely we do. And what's the equation of it? Y equals 8. And what's my y-intercept? If I put in 0, did you get 8 and 1/81st, whatever that is?
649 over 81.
Okay, perfect. I'm gonna take your word for it totally. Since I wrote all this down, can we zip through this? Did any of these match 4 to the x minus 2? Which one? 1, 2, 3. This one right here? Because this is 4 to the x times 4 to the negative second. And 4 to the negative second is 1/16. Is that the only one in that whole list? Yeah, I guess that's the only one who can think. And then F, if it's arithmetic, I don't know how to get this done, but if it's arithmetic, then in the 5th term is 64, and the 8th term is 125. Okay, if it's arithmetic, we're gonna have 3 differences over here. And what's that total difference? What is it? 61. So the difference would be 61/3. The explicit rule would be this. What am I missing? Do I not know? My first term. So I'd have to go backwards and get my first term, which means I would have to do what? Subtract 4 of these from that to get back to the first term, and then that would go there, and that's 61. I could distribute and clean that up a little bit. All right, well, we'll stop there. Take another look at that, finishing that tomorrow. Okay. So I see you tomorrow. I see you.
What do you expect to have?
Multiplying or you adding?
Figure that out. Looks like Tuesday.
80. What color is the power track? Buddy, are you adding or? You're adding.